2, 3.
Dear audience, good afternoon. Dear audience, we welcome you all on behalf of the International Network for Outcome-Based Education. As you know, it has been founded by Professor Dr. William Spady. And we are organizing a series of webinar series for outcome-based education, curriculum design, and many other aspects. So today, there will be a special topic, the metacognitive thinking in successful problem-solving outcomes. The speech will be delivered by the distinguished scholar, Professor Dr. Lovella S. Divinigresha. Let me first, and I am Professor Dr. Mutharul Islam. I am the professor in the Department of Computer Science and Engineering, United International University, Bangladesh, and Info OB and United International University, we are jointly sponsoring this webinar. So let me introduce our distinguished speaker, Professor Lovella S. Divinagresha. He is currently an assistant professor handling courses in mathematics and professional education courses in the Master of Education program at the University of the Philippines, Visayas. She is formerly the head of the Counter for Support for Higher Education and Lifelong Learning in one of the autonomous and distinguished private higher education institutions in Western Visayas, Philippines. But she joined the graduate school program of the university under the Division of Professional Education, College of Arts and Sciences in 2019. Her 17 years in academic work covered expertise in curriculum instruction and research with various teaching and administrative university function experiences. Dr. Lovella is an experienced designer and trainer for teachers, professional development programs in both private and public schools at different levels. She specifically lectures and trains on pedagogical designs, program innovations, and curricular evaluation. She further serves as a consultant in outcome-based curriculum development in different colleges and field of discipline. Her teaching specialization involves graduate and undergraduate professional research and mathematics with special research interest in metacognition and problem-solving curriculum development. And we have a lot to mention for Dr. Lovella. Now I would like to welcome Dr. Lovella. Welcome, Dr. Lovella.
Thank you very much, Dr. Mutaharul, for a generous introduction. And also this time, I wish that everyone is already on set. Let me introduce to you the recent study that I have conducted on metacognitive thinking, which is actually involved in successful problem solving. No? And the very basis of examining the different thinking patterns that constituted to successful problem-solving solution outcomes, no, are found in this study. Okay. Okay, so let me begin by sharing with everyone Let's estimate our webinar time. So we will have two parts. Our first part will be about overview of the study, a little background of it and how the study was created, and 7 themes, the result that include the 7 themes of metacognitive thinking. And then we will have a break of about 5 minutes with the discussion later on, or Q&A of 15 to 20 minutes. And then the part 2 will be on the nature and the nurture factors. As part of the result of the study, these are the factors influencing the metacognitive solution qualities of successful mathematical problem solving, and the very important emerging stages and framework of successful mathematical problem solving, and implications and recommendations that probably can be also responded by concerned organizations or bodies that are dealing with the teaching and learning of problem solving, and even researches conducted for the problem solving. Okay, so we will have a 15 to 20 minutes Q&A also for this part. Okay, so let me read again with you the abstract of this paper, and practically the inspiration where this paper come from. Outcome-based education has meaningfully set direction on how humanity should view life and how education should lead the learning individuals and society into the very essence of its existence and purpose. The complexity of living and learning in the 21st century demand for empowered individuals who can responsibly contribute to the diversity of the challenges at hand. The ability of a person to identify problems and navigate around in order to bring potential solution outcomes and thrive reflects one's holistic strength that begin within. So in this presentation, a metacognitive thinking proposes a big reflective understanding process that can empower every learner to develop such strength and ability in problem solving. So in other words, this is a grounded theory study that proposes very important thinking patterns that we can take into consideration and later on translate or apply them in designing our instructions in our lessons so that we can further improve on the natural ability of our students to think, not only critically, but more importantly, responsive to the making of solutions that are very important when they are confronted with different problem scenario. So seek for the truths that come from the universal source if you want to make a difference for the highest good. So practically, this is the very inspiration that had helped me, in trying to pursue this study, because it's not easy really to understand the internal experiences that are happening in a person's mind. So OBE advocates, as part of the background of this study, OBE has become a very influential paradigm on my part. So it advocates the interest to investigate. It's it truly aligns to what I believe about how we should understand how we should understand learning, how we should understand education. So outcomes-based education speaks of the ultimate essence of education toward developing total learners and eventually of becoming total leaders who are stewards of humanity in the world. And if you can see, if you look at the right schematic diagram, this is actually Dr. Spady's total human qualities for empowerment. So to develop a total learner, we can see that there are 5 important domains that we can look upon and try to integrate whenever we make decisions in all our educational steps and processes. So at the heart of it, for one to be a total learner, that learner should be a self-directed learner, conscious and spiritual by nature. And that learner will become a willing and collaborative worker, a learner who is creative and a complex thinker, a learner who is deeply compassionate community contributors, and a learner who will eventually, or a learner who possesses a competent and unique quality. production of whatever is necessary or whatever is required of the situation. So these are the 5 essential qualities or characteristics that we hope for our learners to develop. But looking back at the fundamental qualities, as lifelong learners, teachers are encouraged to embody the qualities for learners to experience and imitate. Okay, so as teachers, we really do have a lot of responsibility in always putting in our mind the importance of the question why we educate. Okay, so OBE emphasizes life role performances because, of course, if we know mastery learning for basic education, we tend to come up with series of specific objectives, okay, through action words indicative of what we want to observe from our learners. But outcomes-based education focuses on the life role performances because it believes that education prepares the learners in the realities of life that are more relevant to their context. Hence, educational outcomes set by any institution, organization, or stakeholder of the society or community must be of greater significance and relevance to the learners and their environment. So in other words, outcomes-based education look at a bigger perspective, at a bigger way of looking at what must be attained by a learner at a certain period of time. So if you're thinking about basic education from primary down to elementary level, you can start thinking, if you are in an OBE paradigm, you can start thinking what must be the outcome that I would like to see after my learners have move on from one particular level. So these educational outcomes actually depends actually on the institution how they will look at it. So in other words, it's about view, it's about philosophy. And so oftentimes we can see educational outcomes being cascaded to or reflected to program outcomes. If you have a program, if you're looking at a program, and at a very specific and a smaller scale, we look at them as course outcomes when we're talking about subject matter. And at a more specific level, we call them as learning outcomes when we are now dealing with activities or outcomes that we wish our particular subject matter to inculcate or to introduce to our students, okay, to make them learn, as what experience that they have to go through, so that particular experience will really address what we call the life role performances. So allow me to just give you a background of this because though it is about my study, but I really try to weave it there. Because OBE really played a very important. There's a lot of things that we'll have to look into when we speak of outcomes-based education. And we can always begin looking at the learner himself, at that individual person, making him a total person. That person as a means, as a means, not just an end, but a means himself, on the bigger purpose of what kind of community or society we wish to achieve in the future. Okay, since we set it in the outcomes-based education, we set it to be a livable future wherein these individual learners are the means, to themselves for achieving that livable future. They are stewards of that future. So we have here a learning hierarchy. If you can see, it started from discrete skills. That is where we can connect our mastery learning, wherein we set objectives in our classroom if we are in the elementary or high school level. That's why we have our competencies, because we want to see discrete skills. But what are those discrete skills for? They are for more structured tasks. And the reason why, even in the many revisions or advancement of curriculum, we can see that we give performance requirements, performance-based requirements, because we are now looking into tasks that are more relevant to our learners' context. So from there, we move on to higher order competencies, wherein we are giving learners a more tasks, wherein there are more competencies, layer of competencies are being used in order to achieve, in order to accomplish a task, until the time that we are bringing them to a more complex unstructured task. So specifically, if you're going to connect this to problem solving, it's the same thing. No? On problem solving is also a layer of thinking that has to be thought about, and also can be thought as layers of complexities to examine. So from unstructured tasks, it can move on to a more complex functional rules, and later on the real life rule. And so the achievement, actually the main purpose of this is for the achievement of the most complex functional behavior, which we spelled out for the total learners as with these given 5 qualities that Dr. Spady has presented to us. So if you look at the small circles here, they are the educational bodies who are responsible in organizing, outcomes of significance, or in looking at what we think are the most significant outcomes that we want our students to learn, to experience at a particular point in time. So that's the reason why we have early childhood education. So what must be expected from our kids, okay, at that particular point in time? So what outcomes do we expect our young learners to manifest or to exhibit at that particular moment, that particular period of time? In elementary education, secondary education, tertiary, continuing in professional education. So all these things are contributory to, as a body of organization that would contribute to the fulfillment of attaining the total learner that we want to happen. Unless you want to add more, okay, to that, but these are of the many, many things that we want our learners to achieve, and for them to become who we want them to become, for a kind of community or society that we want to have. Well, then we have to be very serious about thinking what really are the outcomes of significance. So if we examine the fundamental life performance roles, we look at the person, the individual, or individuals as listeners and communicators, and basically learners and thinkers. Thinking and communicating, and the rest are doing things. So as thinkers, we are expecting our individual total learner to be implementers and performers. They are good problem finders and solvers, planner and designers. They must be creators and producers. And of course, as listeners and communicators, they can be our teachers and mentors when the time comes, supporters and contributors, team members and partners, leaders and organizers. So this is also one of the framework presented by Dr. William Spady on his founding ideas. So these fundamental roles, if you have noticed, are getting complex in the 21st century. Problem solving has become more challenging. So I think everyone would agree to that. That life is getting complex, and so we're confronted with so many challenges as well at the same time. And it seems like everything, if we look at different situations, there is always problem solving involved. Now, but this time I would like to contextualize a presentation of my study. It's actually on the domain of mathematical discipline. So despite the challenges, we still have the gift of the present and our giftedness, right? I still do agree with that. And I think some of you would like to as well. This study sought to therefore to understand the value of problem solving in the 21st century learning and living. So as part of the background and the analysis of what's going on with the problem solving right now, especially in the classroom, then it's worth really understanding the demand of unending quest on improving our problem-solving skills, especially for our learners, and the development of understanding the brain science, psychological processes, cognitive abilities, and their significant role in learning and problem-solving. Because problem-solving, of course, it's really cognitive by nature, And it's one of the fundamental life role that we have to be responsible of the development, the cognitive development of our learner. So if we know the principle of education, the principle of learning, we know that there are three important domains that we have to develop among our learners. They are the cognitive domain, the affective domain, and the psychomotor domain. And problem solving is actually, it's like a blueprint of everything. No, it's in the mind, but it can also be reflective of what kind of psychomotor skills we are going to develop our learners. At the same time, the effect of our learners as they are doing the problem solving activity. Okay, so I really would like to share this idea of Sternberg. I was thinking a lot. I was thinking a lot about what's happening with problem solving. Why there is always difficulty in doing that. According to Sternberg, he said that there is always a sort of obstacle that prevents one to successfully solve a problem. Okay, my assumption is that there is a need to identify that missing piece of thinking process vital to the learning of problem solving, because we've been used to, like in the context of Philippine learning, we've been used to always teaching problem solving as we are always leading students to ask what is being given in the problem, what is being asked, and we plan about it, and then we carry out our plan on what to do about it, and then we are going to evaluate or check. So that's the usual two-dimensional thing that we ask our students to do when we want them to solve a problem. But for me, it's just a two-dimensional thing. But I do believe that there is the third dimension that must be examined, and probably will be very helpful for our learners to become better problem solvers. So which can be, for me, I believe that a specific set of metacognitive processes responsible for successful problem solving. For that is only my assumption. However, when I conducted the literature review, I always believe that in the power of the mind as it connects to heart and soul. I really believe in that. I believe that, what our action comes from inside, from the mind and the heart. And so it's very important to really understand what's going on inside. And so I tried to examine different theories. In fact, there are a lot more, but I would like to highlight only these important, the theories. Cognitive learning theories try to understand how the mind works, how the individual learner learns. So this was introduced by Piaget, and then we have as well Piaget, we have Bloom, we have Vygotsky, we have Anderson and Krathwohl. Okay, Cato, and then I also look around and try to understand how our mind, our brain processing had been examined, how our ability to think had been examined. So I tried also to explore in the Carroll cognitive abilities theory. Okay, about crystallized learning, and Kaufman assessment battery for children, assessment battery for children. So these are the things that were examined, the theories that help in the examination of how learning or how intelligence work, how mind works. So later on, looking at the physical side of the thinking of the mind, Loria also presented his theory on brain function, and he found out there are three components, that subcomponents, and the frontal region of the mind is responsible for the presence of the metacognitive phenomenon that is responsible for planning, monitoring, evaluating, programming, anything that requires a sort of thinking that is not more than just cognition, but rather it's something that has a regulation. Flavel was the first one to coin the word metacognition. Okay, so upon examining all this thing, actually, Sternberg also shared a very important insight, a very important fact about metacognition. He was able to explain about the three important components of thinking, and he said that there is the highest form of the highest component, which is responsible for regulating the success of the performance component, which is the second level. He called it the lower level the lower component of thinking. Okay, and the first one, which is the knowledge acquisition components, the process involved in acquiring the knowledge. So performance components carry out, that's the second one, carry out directions of the memory to compare two components, compare solutions to the task and other related processes. Knowledge acquisition components are used to learn and store new information. And these three classes of components are contained and called the third componential sub-theory of Sternberg-Streicher theory. So in other words, meta-components tell us what to do. That's the highest level, and he called that as the higher order executive processes. No? So performance components actually do it. So, and what we usually find at problem solving is just a performance. Problem solving is a performance. But am I right with my assumption that there's something more about just looking at it as a performance? There's something that that is going on beneath it that probably could be very helpful in successful problem solving. So the knowledge acquisition components make sure we learn things along the way. Sternberg's theory implies the important role of higher level psychological processes we call metacognition, which we call metacomponents, to effectively impact certain learning performance we call successful intelligence. So a gap was confirmed. I was looking for a theory. What's the latest theory that can help us improve the teaching and learning of problem solving? But I cannot find one that's really pointing out. So the unexplored phases of specific higher order executive processes helpful in problem solving for me is really very important. So where can I find these thinking patterns? So what do you think would be the best source of information that we can use so that we can be given a model of how does a successful problem solver think? And so therefore we have to find successful problem solvers, okay? So let's go back to what is really metacognition. We oftentimes understand it as thinking about thinking. According to Flavel, metacognition consists of both metacognitive knowledge and metacognitive experiences or regulation. In fact, there are three, according to Flavel, he has three categories. He has three variable components of metacognition, meaning what are the things that that we are thinking about our thinking. So one, our thinking about a particular knowledge. Another one, our thinking about what we think about the task. And another component variable is what we think about our thinking involving ourself, the person variable. So these are the three possible sources of where we can find how our thinking thinks what we think about knowledge, about our personal things, about us, and about the tasks that we do. So that is practically how we can make sense of metacognition, according to Flavel, because he's the first one actually to coin this as applied to how the brain works, how the mind thinks. Okay, so in this study, metacognition is seen as a set of active reflective thinking and feeling. See, it's not just thinking, but there is feeling. There are feeling processes accompanied by bodily reflexes. So it's a total holistic way of looking at what we are thinking. When one is solving a problem or finding means and ways to reach a certain point, metacognition manifests an interrelated and total human thinking processes called in this study as metacognitive processes. So they are reflective thinking processes that has the thinking itself, the feeling, the thinking about the feeling, okay, and some bodily movements that are accompanying the feeling and the thinking that contributed to the success of what we want to achieve as our ultimate goal. So in the case of problem solving, we want to have a successful problem solution outcome. Okay. So the paradigm, what do I see? What do I hear? What do I feel and think? So Here's the paradigm. We've been used to, in conducting research, we've been used to using already a lot of quantitative objective findings, information, facts, scientific and scholarly information. No? But my approach is quite different, because since I want to call from a more subjective constructivist approach, then I have the interpretive approach as a way of making a reality about what is happening in the mind. So this is an interaction between me, the observer, and the one being observed. So the positive approach that I use here is the rationalist and empiricist, because I don't want to be subjective per se, but using the scientific tools that we have already. The method or the truth of knowledge extraction is really very important. So this is where the form theory of metacognition in problem solving was formulated. What I need to know and understand. So these are the things that I am thinking with that gap. I made an assumption that there must be thinking patterns that would explain, that would describe what are these metacognitive processes called metacognition in successful problem solving. We need another knowledge, we need another knowledge domain about metacognition. What is really metacognition? We just keep on saying they are awareness, they are reflective awareness about one's knowledge, one's thinking. They are meta-awareness about one's feelings. That's all. Okay. In mathematics, studies of Alan Schoenfeld and all other enthusiast studies of Brown, Jacob C., Paris, they have also studied metacognition in mathematics and problem solving, but still would yield the same construct of metacognition. They would always speak about metacognition on procedural knowledge, conditional knowledge, content knowledge. So these are the things. It keeps on, keeping on the same constructs on describing metacognition. And that is why my investigation extended further to specific objectives, that is to describe the qualities of metacognitive solutions that led to the right solution. So what are really the metacognitive thinking patterns? Qualities, what are the qualities that help in the achievement of the right solution? Second, identify factors. What factors contributed to the emergence of these qualities? Is it nature? Is it natural? Or is it by nurture? Determine the stages of problem solving that require the said metacognitive processes. Because as educators, common to us, we always would oftentimes right away, if we are going to compute or compute a very massive, numerous, huge numbers, we would look for calculators, we would look for our computers. But it's more than that when we speak of thinking. So in problem solving, we oftentimes would like to see what are the steps, how would we do that? So we usually look at the thing like that, look at problem solving like that, right? So in this case, since somewhat the basis or the data will be extracted in a different manner, and so therefore we have to define as well, we have to know as well what are the emerging possibilities on how problem solving was able to answered correctly, how we were able to arrive at a solution, a successful solution outcome. So here are my dilemmas. So what my dilemma, while doing the study, how will I know and understand metacognition? It is really a highly covert phenomenon. It's very difficult. Even advanced laboratories, they're doing a lot of experiments in the mind, but we cannot really get the extract, something. We can extract something else, but this method is different. It's different because it's really very specific to mathematical problem solving. So my disposition about this dilemma is that I just have to trust the universal source, because my maxim is that when we have to acknowledge that there is a universal source, then, and if we are that sincere, and if we are that hopeful and diligent enough to look for that, for the betterment, for the good of something, to seek for the highest good, then you just have to trust and you will find a way. well, there are it's like also a problem solving. I'm also like doing a problem solving, on how to solve my own problem, my own dilemma. So my direction, I am led to find more good minds, willful minds, hearts and hands, who had helped me a lot, in the process of, of finally achieving this very, very humble piece of work, of really trying to describe what is happening in our mind. So with the help of the gifted participants who volunteered in the study, of course, I made use of a scientific process as well on obtaining the theoretical samples. No? So we 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 work hand in hand, and we were able to accomplish what we need to accomplish. So we consider methodological ethics, validity, reliability, some insights, recommendations from different experts of the field that we think are very important. Contribution would play a very important contribution on the conduct of the study. So the research design is grounded theory. I made use of the 3 kind of sampling process. Criterion sampling, I have to set up a criteria as to who will be included as part of the source, the data sources. Okay, that would provide us a qualified, what we say, thinking patterns that are successful in problem solving, meaning they are successful problem solvers. So we need criteria for them. Theoretical samples, because we keep on finding samples that would add to the generated data until it will become saturated and exhausted. And then homogeneous sampling, they have to be at the same group. So the context of this study, you have the key informants profile and the problem solving items. So we did not only consider the key informants, but we also consider as well the kind of problem solving items, because for every problem solving item, we have to examine as well the competencies, the abilities that would be required to answer those problem solving items. Okay, so practically the area has covered. So this is for ages 15 to 17 years old. We have to consider in the Philippine curriculum, we have to consider the 4 important areas. We have the numbers, then in the number sense, then we have the 5 actually, the measurement, geometry, then we have the algebra and patterns, and then we also consider the area of probability and statistics. But examining all the 20 problem solving items involved in the examination of the success in problem solving, algebraic thinking and numerical reasoning competencies in math were the most dominant competencies that are required to answer those problem solving items. So we have really examined that very well. So we set our cognitive ability to be above average. So there are some volunteer participants. They are very, very good. They have very high qualifications, credential wise, champions of mathematics competitions. But of course, in the country, have joined as well international competitions and who have also won awards. So these are important criteria that we set in selection, in the selection process. And we have given them also an IQ test using the Otis Lennon scholastic aptitude test as a product of the nurture. At the same time, some parts which would test on the natural ability of the taker. Okay. So here are the sources of data generation. I happen to develop my own procedure. I call that empathic introspection and the cross-matching of data sources. Successful written solutions to problem items, self-report and interviews, and even observation for actual and video. And we conducted the comparative data coding and inductive analysis. Then we have gone through the open coding, significant responses, eggshell coding themes, and selective coding in order to come up with a grounded theoretical framework. Practically, this is a framework that was based on Corbin and Strauss framework of systematic grounded theory approach. So that's a bit of that. But if you have some questions later on, well, you can email me, or maybe we can answer some of those in the question and answer later on. So here are the results. So as much as I want to see the probable presence or the phases, how we look at how we name them, these thinking patterns, no, metacognitive thinking processes, patterns in the successful problem solvers, I was able to find 7 of them. So the first one, it's about the ability of a successful problem solver to distinguish what type of math problems being solved according to prior learning or experience. So in other words, prior learning or experience, the kind of problem solving that we give to our students play a very important role in their successes. As the complexity in the process of problem solving moves, well, the founding ability or skills must rely so much on the experience of the students. So when the students were asked to describe, to narrate what they can say, what they have experienced, how they look at the problem that were given right after, you know, they answered it, they have this kind of narrative. For one, says it's routine because I encountered in class. It's about interest, so they can even name what's the problem all about. It's the easiest for me because it's about system sub-equation. For the other one, if the other person would say it's routine, the other person would say it's non-routine for the person. No, meaning we cannot, sometimes we teachers, we name it routine or non-routine, but in fact, it depends on the experience of our students. So the other one would say routine, but the other one would say it's non-routine because it's not discussed in his previous experience, and it's something that is applicable to daily life. There is no fixed solution for the problem. Okay, so that's the first one. So it's about the recognition. It's a reflective recognition of a person, of a learner, or of a student, of anybody who is solving a problem about this problem scenario he is confronted with, or the problem scenario given to him at hand. So what can I say about this problem? So there is looking now at a holistic view of what is this problem all about. Okay, it's making sense of the problem. So the second metacognitive process that was found is about one's metacognitive knowledge of problem stature. So a very good problem solver, a successful problem solver, would identify, recognize right away, reflectively recognize a mathematical structure or ideas present in a problem. He may recognize an instance, but many of them would say they have to think about it first. They have to think about it first, whether the mathematical structure that they can associate with the problem is really the appropriate or the right mathematical concept or fact that they need to use in the problem. So one would say, I'm very familiar with it because it's like a combination problem. So you see, they would even use the previous problem item, they would even use that as their common prior experience to make sense of the new problem that they are working with at hand. So regardless of the proximity of time, whether the first problem is given or maybe the problem is given beforehand, there is always the tendency of an individual, a problem solver, who would think of his past experience of how he will appraise this particular problem scenario. Since I was able to read this kind of problem in the first test, so I kind of had a grasp of what it really meant. So I was able to understand this question. I think the question is quite easy for me, so I was able to do it quickly. But as the process progresses, it was also found out that how easy or how hard they are familiar with the kind of problem that they are confronted with, it does not guarantee that they can get it right or not. They will be able to provide the right solution or not, conceptualize the right solution path. Okay. Another is about one's reflective thinking awareness on mathematical knowledge and thinking strategies involved in the problem solving process. So here, this is the third, it's also an important realization in this finding of the study, that we look at problem solving as a combined force of one's reflection about his thinking, of the knowledge he knew about that particular problem, and the thinking that he knew, the thinking strategy that he knew about the problem. So it's a combination of both. So in other words, we cannot separate the knowledge from the thinking strategy. And maybe that affirms my observation that why is it, even no matter how much we give our students different strategies to use from, but if they cannot associate it very well, if they are not used to practice in really making use of this particular knowledge, mathematical knowledge, and practice it as applied to which of these strategies can be most beneficial or most helpful, then it will still, not beneficial, in our instruction. So that's one reflection. I think when it comes to problems, I forget about the formula. Sometimes I resort to trial and error because most of the time it works. It only takes a long time, but it still works. First is, as it is in my paper, that I just first use fractions, but it was kind of hard because I don't really quite understand the problem yet. So I tried to use percentages so that maybe I can try to. So you see, you can see that we cannot separate totally, that if I know how to, if I know how to do the skills and probability, I would right away solve a problem. So there is already an implication. There's also a message given to us, that when we teach math, we have to teach them how to think. It's not an input equals output. It's not an input process output, but in the process, what must go with the math is the thinking. Okay. So the metacognitive knowledge of personal strength in problem solving is another thing that was found out. It is an expressed reflective awareness about personal strength in knowledge and learning, strategy and time consciousness, speed, and everything. I think I know the basic concepts well, and then with the right geometry, I think is talking about geometry, calculations on, like when you memorize the values, that should be precise and it will follow. I know how to solve them, even though without a formula. My strength is I try to solve the problem faster, finding the solution faster to a problem, because I don't want to have questions, wasted time. You can't waste time. So you see, very important is that when we teach math, we need also as well to teach them how to think. Number 5, this is also very important. It shows reflective awareness of one's own emotions and attitudes experienced during problem solving. This is what really triggers them. This is really what sustains them. This was something new, and it required some critical thinking. I really need to think. I really like math, so it kind of disturbs me when I cannot answer the question. So there are emotions involved. The value, the valuing, the attitude, it requires some critical thinking. Not really confident, but I am sure of my answer. I just want to solve it fast and make a job done easy. So you see, they have a different kind of disposition when you speak of successful problem solvers. They're very, very different. They're very, very intelligent individuals, but they are so full of attitude when I listen to them. A meta-awareness of being engaged in thinking while bodily movements. So this is also one important thing. It's a realization that, but I know, I do believe that many of us, when we are solving a problem, we oftentimes, we have not noticed that our hands, our eyes are moving, while we are doing a problem solving, while we are thinking. Even we're not doing problem solving, some of our hands, some of our body parts are also moving. There's a radical theory about it that saying it's not just the mind that dictates at all time, but it can probably, like, there is almost a simultaneous parallel processes between what's happening in the reflexes in the brain. And so that's what can explain why we have psychomotor intelligence, like those who are, very good in car racing, biking, any other psychomotor bodily movement, competitions, that if you are a cognitive person, you try to think and you try to join, you cannot even win. because there is something unique and different from the psychomotor intelligence. So it can also help. So in other words, what does it imply to us as teachers or as educators? We have to engage our students to really develop reflexes, appropriate bodily movements that can suffice metacognitive thinking or thinking, cognition, or even just acquisition of knowledge. Remember, we have three components according to Sternberg: acquisition, performance, and then we have the higher executive processes, which is responsible for regulating the performances for it to happen. Okay, and that is the role of metacognition. So like Pat said, look upward. I try to remember if what formulas are needed for the problem. I try to analyze that whenever he's doing something, he analyze and see patterns. Then I read again and I try to write away what I have thought. Then if I can't see any, I look up again and thinking again. So while looking upwards, it involves the eye movement. The other one says, I'm resting on my chin. It's in a vernacular. I analyze. The one is saying that he is trying to rest his chin. Whenever he did that, he is analyzing a problem, and then he tried to read it and try to, to break down what's in the problem scenario, and then he keeps on analyzing and understanding the problem. So every time he did that, resting of his chin on the table. So you see, we have some bodily movements that we are not really aware, but they are very helpful in making us realize things. Now, I would like to present, this is actually the seventh, I forgot to write there, it's the seventh theme. We called it the metacognitive solution qualities, okay? So we found this, I think, is the best contribution of this study because these are the control qualities that we found controlling the 6 other. Those 6 had been in the studies already, in the many articles in problem solving. But what is unique about this study is the finding of these 10 microprocesses, which are responsible for regulating those 6 themes, so that they can better come up with a successful solution, with the right solution in the process. So they are diagnostic, scanning, searching, referencing, direction steering, rectification, effect, restoration, pattern seeing or seeking, predictive, evaluative, natural flip of thought, time consciousness, and control. Okay. So the metacognitive solution qualities regulate the other 6 metacognitive processes. So open codes from written solutions and interview responses and even narrations in thinking aloud discovered the metacognitive problem solving solution qualities as the emerging 10 micro metacognitive processes observed to be regulating the 6 metacognitive knowledge responsible for the achievement of successful routine or non-routine mathematical solutions. So the 10 emerging qualities are also termed in this study as the metacognitive solution controls. Okay, so if you look at them, there are 7 of them, and we can see their interrelationships. So we have the metacognitive knowledge of problem typology, the ability of the successful problem solver to make sense of the problem, whether it belongs in his past experience or not, whether he is capable of trying to figure out possible solutions, or if not, if something new, find a way to figure out what can be probable solution to help him succeed in attaining the right answer. So metacognitive knowledge of the problem's nature, the ability of one to reflect upon the mathematical structure that he assumed somewhat to be associated or to be of use in that particular problem scenario, and keeps on thinking about that, how in what way it can fit in to help in the process of conceptualizing the successful solution outcome. And third, the meta-awareness of mathematical knowledge and thinking is telling us again that they have to come together. So the experience of learning must promote both the knowledge and the thinking acquisition. Okay, so that's the good lesson that we can get from the third theme. And the fourth theme, metacognitive knowledge of problem, personal strength. Then it's very good that we kind of make our students aware as well that they have to know what are their weaknesses, what are their strengths, and what are the limitations, and what are the other strategies that they can make use so that they can transcend above it and find a way, navigate around in order to reach the point to which we want them to reach. So 5, metacognitive knowledge of emotions, beliefs, values, needs, and attitudes. And we have to develop as well their attitude toward it. And metacognitive thinking with body, motion, experience. And of course, the most important theme, which is they are also thinking patterns that serve to be the characteristics, the qualities why we have a successful metacognitive solution. The one responsible for processing, and the third, higher executive processes, the third component, responsible for making the 6 being utilized in the process to conceptualize a solution that is successful. So number 3, therefore, is called the core phenomenon among the 7 eggshell themes, because all of them, the 1 and 2, these are the important backgrounder that can help trigger the reflection of the mathematical knowledge and thinking. And what sustains the mathematical knowledge and thinking are one's ability to identify or to reflect among themselves what they can give, what they can use as far as their personal strength is concerned, what knowledge and values and emotions and beliefs and attitudes that they have sustain the core phenomenon, the mathematical knowledge and thinking responsible for finding that very important solution that would lead to the successful outcome. And of course, with the body, motion, experience that accompany the thinking processes, and the regulator. So that's why it's called core phenomenon, because all of the other themes are very important in the process of mathematical knowledge and thinking. So it is a very clear message that in instruction, there has to be a thinking that must be part of learning, of giving knowledge to our students, mathematical knowledge or content. Okay, so since 7 regulates, okay, the 10 of them regulates. It was also found out in the study, that the evaluative microprocess is found to be regulating all of them on top. So it even evaluates the diagnostic ability, it evaluates the scanning, searching, and referencing. It's the whole process is evaluated. The reason why in so many steps being presented for problem solving, there is always the part that check or to evaluate, to evaluate or to check, because it is at the surface level. It's the reason it's always the first thing that we would see, as part as meta or reflective, reflecting upon whether what we have done is right or not. So it's always at the top or at the surface level, so we can easily see that. But what is good that we were able to discover the 9 others, the diagnostic ability of the mind, okay, to detect the weakness or the strength of its logical thought, its reading, its understanding, inferencing, okay, either doing it deductively or inductively. So the mind is capable of diagnosing whether it's doing not good, right, or not. Scanning, searching, and referencing, direction, steering, rectification, effect, restoration, pattern seeking or seeing, predictive, natural flip of thought, time, consciousness, and control. So here they are. So to better understand the metacognitive solution qualities regulated, the 6 other themes that are responsible for conceptualizing a successful solution outcome. So for diagnostic, open codes reveal this ability of one's thinking to detect its weakness or difficulty or strengths along the experiences in the problem-solving process of understanding a mathematical problem scenario or context, conditions, main idea, formulation of a solution, and execution of mathematical procedure or computation in a problem-solving task. So we have some sample narratives from our volunteers, difficulty in understanding. He is very much aware which kind of which part of the problem scenario is getting into, facing a difficult situation. First, I don't understand this 1 mile long. I can't understand. It means only 1 mile though throughout the earth, or is it's the wind? So you can see the way he would express himself, what he understands or not. He keeps on repeating, rethinking about what he is thinking as part of the process of trying to make things clear, until such time there is a clarity of things that he is trying to understand. So in the scanning, searching, and referencing, Open Codes identified scanning as a quick recall of several relevant mathematical concepts or procedures to use. So very important are the facts that we teach our students. Searching is a metacognitive quality of thought that looks for a mathematical knowledge or a mathematical strategy. And referencing is a natural tendency to make use of previous problem-solving experiences, relevant mathematical knowledge and thinking to the problem, or similar mathematical strategy applicable to a given problem. So these metacognitive qualities were observed to be one's thought, way, or means of making sense and figuring out solutions for a given problem scenario. However, let's take note that success of this meta-control depends as well in the accuracy of the mathematical knowledge available in mind. So even if the problem solver is very much aware of a mathematical knowledge, but if it's not accurately processed or applied, then there will also be a possibility that we cannot achieve the right solution. Okay, after 5 times of failing a search for it, I remember how to solve it. The only thing I can remember when I learned it is that I don't know the meaning. I'm not really sure about the meaning of the fraction, but it needs to be in reciprocal. I cannot answer this specific question. So over time, I think I was frustrated. So you see, they even experience frustration with this specific question. So then I search on it, but keep on searching. So there is something on them that makes them different from those who cannot, successfully solve the problem. Okay, so direction steering is a solution pathfinding. Open Codes identified ability of thinking to reflectively create a set of directions toward achieving its problem-solving goal. From making of assumptions to formulating of equations, from trying out different forms of mathematical strategy to procedural execution, from calculating numerical equivalence to ascertaining outcomes accuracy, all of these were found to illustrate an ability of the mind to control things into a certain route of thinking that would lead to where it tries to find or go. Okay, so we have also examples, some snippets. No? I tried increasing the other value with higher interest so that I would get an increase in the possible interest. So you see, they keep on doing, they make use also of the trial and error. No? If they cannot build equation, if they cannot go the usual algorithmic way, they would find a way. Okay, in order to conceptualize what's the best possible strategy, thinking strategy they can use so that they can have an accurate solution outcome. For a while, what is the fastest way to compare objects? So suddenly, automatically, it just come out that I have to divide it, because when you divide it, I could make a much faster result because there's only one different apple. So thinking patterns can be seen, how direction is being set, in their thinking, and it always shows a very logical way, of inducing or deducing logic or statements. So rectification effect is a natural tendency of the mind to reflectively correct the detected error or mistakes in mathematical knowledge and thinking, mathematical thinking strategy, or procedural execution involved in mathematical problem solving. So they have the ability. So good problem solvers, successful problem solvers, once they diagnose something that there's wrong, they have the ability to rectify it. No, that's how good they are. So if I may share this is a simple fraction involved to a mixing of paint problem. So first I thought, since it's added to 1/8, I assumed that it would be 9/9 because 9 parts. When I tried to transfer it back, it didn't sound right. if I transfer 9 over 9 and a 1/8 again, it would be their amounts so different because of the adding of the 1/8. I thought it would be 9/9, but it was wrong since the 8/8 plus 1/8 is supposed to be 9/8. So you see the logic. So I tried to add it and it's more than 1 gallon. And this one has missing some parts, so it's wrong. I tried to think that it's supposed to be 9/8 still if the denominator would still be 8. So there is a rectification effect that happened in the mind upon series of logical assertions, reflective assertions, reflective thinking of their thinking, whether what they are thinking is right thinking. Okay. Restoration is about a character of the mind that automatically retrieves previously thought solution paths when stumbling blocks occur. So in this case, like for example, maybe I already tried fractions because I thought it was easy here, but much more complicated when I got here. So I tried to went back to percentage. So you see, there are some alternative routes or paths that successful problem solvers can choose from. Then when I was unable to get it, I went back to my factoring, then got the right answer. So they always have a backup. Pattern seeing or seeking, mind's tendency to find or naturally see patterns of thoughts over related problems of similar solutions, processes of the past, experiences, and patterns of numerical algorithmic reasoning being needed in the present condition of a given problem. You see, there are even some, why I say pattern seeing or seeking, because of the trend in the curriculum of algebra and patterns. There are already some pattern strategies that had been taught to our students, but there are some naturally gifted pattern seers. They do not seek, but they can just see. Okay. So it's like problem 8. To shorten the time it takes to create an addition, I tried to do was to randomly pick any amount again to match the given interest. First value is 3,000 for 5% and 2,500 for the 7%. It's just random test. I tried to compute for the 5% of this and 7%, and their sum is not equal to you know what is given 345. That I tried increasing the other value with higher interest so that I would get an increase in the possible interest. They find strategy on how to use patterns at the same time logical thinking, no? And while they are reflecting whether the proportions or the percentages are giving them what they are looking for. Okay, so the increasing value in here so that I might get 2, 2, 3, 4, 5. So if I look at their written problem solutions, very, very neat. And you know, very successful problem solvers, when I tried and tested the problem solving items to college students, for 1.5 hours, they cannot finish the 10 item. But for this individual, they're very good. Some of the items difficult, they would just answer it for 1 minute, 2 minutes. Okay, the longest so far is 3 minutes in speed, but they're very, very good. And it's a very good, you know, model to see how they think. And from there, maybe we can develop some instructional designs or strategies that can help us, you know, improve as well the thinking ability of our students. Predictive, we often heard about predictive, but in the problem solving context, the ability of one's thinking to foresee certainty of success due to the advantage of the assumed mathematical strategy or certainty of reasoning. Okay. For a while, what's the fastest way to compare objects? So suddenly, automatically, it just come out that I have to divide, because when you divide, could make a much faster result because there's only one different apple. When you divide it into 3, that's the only way you can divide. They're very, very good. They're very spontaneous, and they can really explain what's happening to them. Okay. And evaluative, the tendency of thinking to ensure quality and certainty of the whole conceptualization and execution process of a problem's mathematical strategy and outcome. It encompasses the total system of the solutions analysis. If the diagnostic is only point per point diagnosing what is happening, evaluative is encompassing the whole system, the whole answer, the whole thinking of the solution process. It indicates patterns of thinking like constant monitoring of understanding and comparing alternative problem-solving solutions. It also demonstrates reflective decision-making about choosing from available options of mathematical strategies at hand based on one's mastery of mathematical knowledge and thinking skills. And it checks the mathematical procedural reasonability, consistency, and outcomes accuracy. This one unique is a natural flip of thought. Only one of them was able to manifest this, but I think this deserves because we're exhaustively looking for more thinking patterns. So, and when I reflect this upon myself, and maybe for others as well, when I ask others if they're experiencing this, yes, we did, we are. This is a natural ability of thinking to execute sudden total understanding after sensible outcome is arrived. At first, you do not really understand the problem. You just keep on doing numerical trials, calculations, until such time that when you arrive at a sensible numerical value, that it's the only time that you understand the problem. And I think this is very, very, very familiar and very similar to our experience as well. It oftentimes that we do not know, that we really do not understand the problem, but we were able to solve the problem after we have made some computations. Okay, it's a non-verbal way. Okay, while others do the verbal way, this is a non-verbal, very good in coding, very good in symbols. Time consciousness and control. Open code said tendency of one's thought to regulate time during the process. They're very much aware of the time. They keep on thinking whether the time as well is a detrimental, is a hindrance to their success or not. Okay. Then again, I skipped because I really didn't understand. Okay, so I think the first part is done. We take a break. We will take a break. And while taking a break, I hope you can make a reflection in what way we can make use of the 7 themes in teaching and learning research. And then after 5 minutes, for 15 minutes, we will have a question and answer, or maybe a point of discussion to discuss the question presented here. I may now turn over you to Dr. Mutaharu. Thank you.
Okay, welcome, Dr. Lovella. So it's really a nice presentation, and we have already received some questions. So we'll be answering now, or we'll be taking some time,
Okay.
as you mentioned, for 5 minutes break.
Yeah. So I think we can answer that after 5 minutes.
Okay.
And we
so
can also give others the chance to think
Okay.
What they can answer about this.
Okay. Dear honorable audiences, please write your question in the chat box. Okay. So we are recording all the questions, and in due time, you will be getting your answer. And we welcome you all to join the Global Virtual Summit 2022 that will be held on August 12 to August 14. So you are most welcome to join, and you can also submit your proposal to the virtual summit. So the information is already given in the chat box. You can send your proposal to the given email address, and the deadline of the proposal submission is June 10, 2022. So please consider the submission of the proposal in the Global Virtual Summit of International Network for Outcome-Based Education. So we have received some questions. Dear audience, please don't hesitate to write your question in the Vertex live chat box. Again, we welcome you all to the webinar series. Please write your questions in the Vertex chat box if you have any. Yeah, we are noting all of your questions and we'll be answering after a few minutes.
Dr. Mutaharul, maybe for those who are still with us and are not taking or done taking their break, if they can share with us what they think about the question before we still have like 2 minutes to answer the question and answer. If they want to share something, maybe they can just write it in the box.
Yeah, they are writing already.
They can write their brief answer in the chat box.
Yeah, they can write their questions as well as the brief answer also.
Yeah. Do we have some answers already in the question?
No, we didn't receive any answer till now.
Okay, so at least it's sort of a reflection for them to bring with
Yes.
them.
Yeah, dear audience, please, as Dr. Lovella requested, you can also note some sort of response based on your questions also, or what type of answer actually you are expecting, so it will be easier to get the questions.
Dr. Mutahul, there are a few questions. Did you pick them up?
Yeah, I have already collected around 5 questions.
Yeah, can you please, did you give them to Dr. Lovella so she can answer them right now?
Yeah, I will be asking and just reading the questions.
Yeah,
for
please,
Dr. Lovella.
so that Dr. Lovella can answer the questions. The questions
Okay.
are already available in the question tab.
Okay, fine. So Dr. Lovella, should I
The
read the
first
Yeah.
is from Adrian Guento. So you can, replay
Yeah.
his question and go to the other
So,
ones.
so the first question by Dr. Adrian Guinto, what you can advise the higher education institution and Commission for Higher Education? I think it is the Philippines Organization for Higher Education. So what you can advise the HEI and CHED in thinking or in rethinking the implementation of OB in the Philippines? Thanks. This is the first question. Dr. Lovella, is the question clear to you?
Yeah. Okay. Well, it's really a very challenging question. What can I advise? Then we have to revisit. We have to revisit the fundamental framework, the paradigm, the view of outcomes-based, authentic outcomes-based education, and then we can integrate that into our framework. In fact, what CHED right now is having is already an integration of the framework, but not all the paradigms are there into the system, into an organized body of what they call OBE framework, wherein it plays a very organized system on the important functions of curriculum, student services, faculty or resources, and even continuous improvement process monitoring. In fact, the mechanisms are there, okay? But as to really integrate the heart of the outcomes-based education, I think every institution is empowered to do so on how they are going to put that, to intertwine that into their system, into the university system, in terms of in terms of their graduates, the kind of graduates. I think you are doing that. Okay. The implementation of the outcomes-based education, this is a philosophy. So, and there are some values and beliefs that the OBE believe, no? Unless you disagree that there is something different from what the Philippine Higher Education Institution and the Commission on Higher Education is doing, then find a gap and fill that. Okay. But as for now, when I look at the framework of the commission, they are providing us a framework for how to run mechanics, no, and how to ensure that the system is organized in that particular aspect. I hope I have answered that.
Okay, Dr. Lovella, we have received some other questions, and Dr. Adrian, he has some other issues. He mentioned that these themes can be used as a guide in determining how students are using metacognitive in solving problem, not only in mathematics, but also in other disciplines.
Can you repeat that, Dr. Mutaharul? Sorry.
Yeah, the same, person, Adrian Guinto, he has mentioned these themes can be used as guide in determining how students are using metacognitive in solving problems, not only in mathematics, but also in other disciplines. So metacognitive thinking in other disciplines.
Okay, so I think Adrian is answering. Is he answering the question? I think he's answering the question that it can serve as a guide. In fact, yes, you're right, Adrian. Yes, it's not only in mathematics. In fact, when I tried to make some, sort of collegial discussions or conversations with some of the colleagues in some other fields, when I tried them to think, introspect as well, whether all these thinking patterns can probably be used when they are doing political analysis, when they're doing poetic analysis or poetry analysis in the language, in the literature. They said yes, they believe that somehow these thinking patterns are really very experiential. They are really there. So thank you, Adrian. In fact, that can be used as a guide as well for other fields to consider, when you are trying to do some similar task to that of the problem solving.
Thank you, Dr. Lovella. We have received the second questions from Izari Mashita. The question is, how can I apply metacognitive knowledge of language as second language? Thanks in advance. How can I apply metacognitive knowledge of language as second language?
Metacognitive knowledge of language as a second language.
Yes.
Okay. Metacognition plays a very important role even in language learning. I'm not an expert in language, but because I'm in mathematics, but if you transfer metacognitive knowledge of language, for example, I know about language, right? I know about language, then I have to keep reflecting on how to make use better of the language that I learned in learning the language. Am I answering you? Or are you asking how these thinking patterns can be transferred into the learning of language? Is that what you mean?
He has a counter question also. So can we say that metacognitive is gazing or diagnostic ability of students?
Guessing? Is it guessing?
Yes. Is it guessing or diagnostic ability of students?
Yeah, it's one of the thinking pattern regulating the other 6. So if you can see here, the first one, sorry, it was hidden by the seventh, the title here. The first actually, okay, the first Here it is. It's actually diagnosing. In fact, it also makes intelligent guesses, inferential questions, inferential statements, no, while they are processing and finding a more appropriate solution path for a particular problem they are confronted with at hand. So diagnostic ability is one. So what is good about this, because when we are aware that these are very important in successful problem solving process, we will be able to strengthen, no, find a way to come up with activities that our students may strengthen all these thinking patterns that would lead them to a better finding or conceptualizing of a problem solution.
The third question we have received from Firman. Mr. Firman, the question is, does students need to be aware of their metacognitive skill to make them a successful problem solver?
Yeah, I think so. That's the fact that they have to be aware about how they think. How about they think about their thinking? That's really a very crucial, what is this ability not to develop among our students, because remember, it's one of the 7 themes here, metacognitive knowledge of personal strength. No? They have to be aware of what they know in terms of the content knowledge, in terms of the task on how to solve a problem, the different strategies on how to solve a problem, and what are the things that they are very good at, what are the things that they are not good at, no, and the things that would keep them going in solving the problem, and what are the things that do not keep them going, no, and all the other possible things that they would need when they are doing the problem solving. So it's really very a helpful information for our young learners, that they know themselves very well.
Okay, fine. The fourth question that we have received from Mulugeta Tisom, his question: why do you want to focus on mathematics? Do you think students' thinking should be patterned by the classroom teacher? Is that possible to measure the extent of students' thinking about a lesson? Thank you all.
Thank you for that question. Yes, in fact, number one, in mathematics, because this study is really on mathematical problem solving. And that is why I was asking if what can you say about this, when about the 7 themes, in terms of in what way you can make use of it in terms of research. Because if you are interested also of conducting a similar research in another field, then it is a very good one, because it can as well confirm what are the similarities or probably the differences of the metacognitive thinking patterns that we can find from the other fields that may not as well be found in mathematics, or might as well be useful in mathematics. Okay, and what was the next question? Is it about what was that again, Dr. Mutaharul?
Is that possible to measure the extent
Okay.
of students' thinking about a lesson?
Yeah. In fact, the indicator, if we cannot right away, yes, we can do that when we ask them questions. If they reach a particular stage, for example, if they can predict, then come up with some questions that would allow your students to predict. Come up with questions that would allow your students to diagnose, and they will be able to diagnose. You come up with questions that would allow your students to manifest whether they can scan, they can search, and they can reference, then they can do that. In fact, there is already it was a 1980s instrument, I think. One of my graduate students made use of that as a measure whether there was an increase in the metacognitive awareness capability of individuals, no, upon using all these controls, all these thinking patterns, no, in making an assessment task and try to make some activities and questions that would really engage students to, practice all these thinking patterns. And it was found out in that MAI, that's Meta Awareness Inventory. It's also an inventory of metacognition. It's a standardized test, and it was found out that it's really there is an increase in the metacognition. But when you ask that whether we can measure that, then we can make use of the criteria, the quality. We can come up with a rubric. So what must be the ideal thinking, particularly for a particularly in a discipline, a specific discipline? What can be an ideal answer to a question that focus on a particular thinking? So this is what is good about this study, because it has given us the phases. What we know about metacognition before is just metacognitive knowledge and regulation, but other than that, we do not have the specific thinking patterns. And now we have at least 10 right now, and we have 6 other domains that somehow can help us already make decisions, inform decisions as to how better teach our students or even assess our students. Criteria, quality, set the standard. What's the best thinking, or what's the best answer for a particular type of thinking?
Okay, we have received another question from Gitahun Menkir. Appreciating your presentation, I would like to ask you a question. How do you relate 10 micro metacognitive process with that of Bloom's taxonomy? How do you relate 10 micro metacognitive process with that of Bloom's taxonomy?
Yeah, thank you for that question. Bloom's taxonomy is about evaluation. The highest of it is evaluation. Then you go down to synthesis, application, analysis, application, and understanding, comprehension, and then you have the knowledge level. So in fact, these are all hierarchies of thinking. They are cognition. Okay, they are cognitive processes. But if you try to think, if a person try to recall an information, knowledge level, right? So the action is to recall, to identify. So usually, if there is already a solid and a fluid intelligence, automatically the response will come out. But for those individuals, okay, for example, who are, who would like really to make sure that whether what they thought to be an answer for that knowledge or recall question, okay, is right or certain, then that's where metacognition comes in, because he has to start thinking quickly whether that knowledge that he has in mind, responding to the knowledge question, is right or not. But even if sometimes we say we are delivering an automatic response to that knowledge level question, but yet oftentimes we might not even notice that we are even doing metacognition reflection. No, we do not even notice, because there are some, the brain works so fast that some of it are very, very minute and very difficult to notice or observe. So, but metacognition is the one that keeps us rethinking whether that thinking is right or not. When you move at the understanding level, there is still metacognition in there. These 10 controls there are possibly, working as well. Understanding in reading, understanding, since this is a word problem, we can associate a word problem like a reading a particular paragraph. So there are different frameworks of reading comprehension, okay, or understanding. One can be reading at a literal sense, understanding at a literal sense, inferencing, reading between the lines, or probably you are critically thinking and trying to understand all the other components and elements in what you are reading. And so you can, in order to fully arrive at a particular level of understanding, like for example, just literal understanding, we cannot just understand it away, right? So it's possibly that we still also diagnose whether what we perceive or what we understand about the first time we read that particular phrase or particular statement or paragraph is right or not. So we diagnose even if we are understanding it right or not. That's where diagnosis can come in. But as we as the task of understanding is getting complex and bigger, expanding as it is, all patterns of thinking can possibly be pronounced. So there will be a part probably that in some words there you might to scan, you might to search, and might want to reference, do some referencing just to ascertain you know, to make sure that you are really understanding it correctly in the understanding level. In the same way in the analysis. In analysis, we break down all the important ideas in a paragraph or in a problem scenario, or for example in a story. We try to break it down with what we want to look, no, in breaking down. Then every moment of a step that we extract one from the other, it's possible that diagnosis will come in. It's possible that we scan whether the process of extraction is right or not, whether the process of understanding a particular word is right or not. Then when making an appreciation of the whole understanding or analysis, then sometimes we also experience that that we have to rectify, because we realize that there are some inconsistencies in what we perceive or what we understand a particular scenario. I hope I am making sense. So as the task of reading and understanding is getting bigger, this 10 can happen. Sometimes the task is small, so probably the thinking processes, there are parallel processes too small to be noticed.
Okay, thank you, Dr. Lovella. We have a lot of other questions. Do you think that we should, encourage other questions, or we will be asking in the next session?
Okay, maybe we can reserve that, and they can have, they can improve further on their question as we continue with my discussion. Maybe we can rephrase that later on.
Okay, thank you once again. So we'll be continuing with the lecturing session, right?
Yeah. Okay.
Okay.
Anyway, I have few slides left, so I hope we can entertain more questions as much as we can.
Yeah.
Okay.
Thank you.
Okay, thank you. Now, right, sorry, I have to remove this. Okay, so let me talk about the nature factors. So the open codes also identified natural or inherent qualities of thinking patterns or other external reasons that cannot be directly attributed to school learning or training. These individuals were also, recognized, in details in terms of their background. They were also interviewed in terms of how they were raised by the family, in terms of their schooling, and what contributed to their excellences, to their very beautiful performances, excellent performances in mathematics, and what made them thrive in the competition and bring home many awards. We were able to delineate the nature and the nurture factors from the fact that there are those pattern of thinking that you can right away attribute to the one which is a product of the nurture. And so the rest of the thinking patterns that we cannot surely attribute directly to the training, or in school or in home, we attribute it to the nature factors. So they are natural verbal, the language factor, or the nonverbal numerical ability, intuition, insights, emotions, and mental attitude associated to micro metacognitive processes or qualities responsible for the occurrences of the others. So in other words, we can look at the 10 micro metacognitive processes as the natural factor, as they are all built in to any individual being. And so we cannot see directly the consequence of the training of the school and the home, wherein it has associated directly to diagnostic ability, to scanning, searching, and referencing, the ability of doing that, and the rest of the other microprocesses. And that is why I would encourage as well other researchers, if you can come up with a study, to try to link an association of home trainings also to how they are affecting or influencing the 10 micro metacognitive processes. Okay, so these are the natural factor that contributed to the solution qualities. And later on, I will further explain more what are the other possibilities and the probabilities why nature factor are attributed to the 10 microcontrols. Okay, so the nurture factors, open codes identified explicit influence of learned or acquired mathematical knowledge and thinking. So most likely those who were learned from school, like the mathematical knowledge and training that they experience in the classroom or in competitions are product of nurture factors. Meta-awareness of mathematical problem written structure, its typology and nature, meta-awareness of own strength or weaknesses in mathematical knowledge and thinking skills and strategies acquired from home or classroom learning and training experiences. So if you look back again to our thinking patterns with 7 domains, we look at the first two themes, the typology and the problem's nature, as our initiator of metacognition. It's the one that, if you think of a gear, if our problem solver has a rich experience on the different kinds of problem that they have encountered, that they have solved, and they have that rich experience in terms of the different mathematical structures, knowledge, facts, information in the past, this what triggers the the grinding of the gear towards the mathematical knowledge and thinking. So that's why we call it the initiator of metacognition. And so what sustains the thinking, the core phenomenon, are actually the three. We call that the driving force or the intervening condition that keeps them thinking, conceptualizing a probable solution that can really answer what is being looked or find from the problem. So the first three, we can see this if we are going to match this with that of Flavel, task variable component. So we can say that the first three is what we call the metacognitive problem solving task related knowledge. And the other three, we can attribute this to as the solving affect and problem solving affect and motion experience. Okay, and we can see that this 6 has something to do with the nature, what we call the solution qualities, because it was even proven in one of the studies of my graduate students. They found out that all the students, regardless whether they perform well in the problem solving tests or not, they all have a certain amount of the 10 micro metacognitive processes. They have a certain extent of that. In other words, it depends on the quality as well of the 6 themes. Which is a product now of what you call the nurture factor. Okay, this implies in the teaching and learning that we can start looking at experiences and activities that we can give so that it can improve students' personal strength, their emotions, beliefs, values, and the bodily motions associated to it when they are trained to do the problem solving that would sustain them to keep on thinking in the core phenomenon, the meta-awareness of mathematical knowledge and thinking. So the key, therefore, of the success is that there has to be accuracy. There has to be a very rich experience in all the 6 themes, so that this part here, the 10 microprocesses, will be able to regulate very well. Because even if how good the student in diagnosing, scanning, searching, but he cannot mathematics field is really, really very, highly objective. So if there's something wrong with the knowledge domain, then everything will also, by default, will not be able to reach at the right solution. Okay, but in terms in explaining of the nurture and the fact and the nurture and the nature factor, well, the only limitation of this study, because we get all this information from students who are above average, but well, of course, we do not know if that ability is given before they reach 15 or before they reach the age of 15 to 17. We don't have a way to, we did not have the way to, a way to determine how's their IQ at the very beginning. And so we cannot say that, what is this now? The kind of, or the quality of the microprocesses that they have. Would this be a product of the nurture? But even if this is, let's say, for example, if at the very beginning, they have lower value of their ALSAT, a lower IQ, for example, at the beginning, and now they have this above average at this point in time at 15 to 17, at the age of 15 and 17, then we can say that the nurture factor has done something to these 10 microprocesses. Okay. But if in the case that at the very beginning, for example, it's an assumption that they are already very bright before the nurture part, and then we cannot have a way to determine as well if these success of outcomes really contributed or contributory as well to the old nature at the very beginning before the nurture. So there are so many assumptions that we can formulate around this. But what is important right now that we were able to distinguish, identify important thinking patterns that can help us in the process of teaching and learning when we teach our students problem solving. And this gives us a further message that accuracy is really very important. We have to be very precise and accurate in the interpretations of our mathematical facts and concepts, and the strategy, the thinking ability to apply them, apply these mathematical facts, processes, concepts, and procedures for them to be able to be successful, in the application of their mathematical knowledge in the field. So that's why this 10 we call this metacognitive solution qualities, or the control character, which eventually emerged the metacognitive stages or part of a successful mathematical problem solving. Okay, so if you look at this is the conjoining stages or part. So if you look at the different frameworks, for example, Polya has its own framework of mathematical problem solving. You have to plan, you have to carry out your plan, you have to check it. So there are steps. We've been used to doing like those steps. But why is it that not everyone really can find a better solution? Not all of us. So what I'm trying to say is that we look at the problem solving as a different perspective. It's not a two-dimensional, just simply a front view, but we have to look at it as well at the third eye. So in other words, this is why this study is so helpful in better understanding the problem solving, because it was found out in this study that what we used to know as there is a part wherein we conceptualize the solution and we carry out the solution, we plan for the solution. In fact, these successful problem solvers in this study, all of them said that they did not plan. It's just a product of their natural thinking process. It just, come out of their mind naturally. So in other words, there's amount of practice or nurture or experience that they have built within, given also their natural ability. So we have to be very extra careful when we are teaching problem solving. So in other words, it's not focused on the step 1, step 2, step 3 on how to solve the problem, but rather investing more on the development of thinking. thinking abilities, where we are given now a guide. We are given now the patterns of thinking available in this study. So it says here that the big understanding process actually is the whole important, the key, it's the key of a successful problem solving solution outcome. And it encompasses even the process of conceptualizing the solution, that it goes with the kind of different thinking strategies that it's being used in utilizing the mathematical knowledge domain. And it also encompasses the execution of the solution strategy. So the big understanding, it has to understand conceptualization and execution and all the interplaying variables that are necessary for conceptualizing the right solution and even for the execution of the solution study. There are some studies telling us that more time are allotted to conceptualization of the solution strategy compared to the execution, where there are already procedural and computational performance are happening. So that we can arrive at the successful solution outcome. So it's a conjoining. We should not take it as compartmentalized, but rather it's a whole big conjoined process of thinking. That's how we look at problem solving, so that we can see, according to Sternberg, that if we consider problem solving performance a lower level thinking, it will just simply executing, utilizing knowledge that had been acquired in the lower level of thinking in the acquisition component. But to make it more efficient and effective, we have to apply the IS, the higher executive function, wherein there are more strategies, thinking regulation strategies are happening to ensure that the performance will really be accomplished at a certain point of desirable expectation. So the big understanding process encompasses the two other metacognitive stages: visualization of concrete images of the problem scenario, decoding or detecting the process of identifying ambiguity or clarity in meaning or mathematical representation of problem conditions. These students are very good. These problem solvers are very good in detecting which part is ambiguous, and they would work out for that. If they are compartmentalizing things also in their mind, but they know where they're going. Very, very clear and very, very precise and definite on how they process. But the regulation of what they're thinking, they think about what they're thinking, that's what makes them more successful. Deciphering or hypothesizing logical statements about the problem scenario, maneuvering from false assumptions, and confirmation of the correctness or reasonability. So we teach our students how to, if they are they are answering the problem, we teach them how to check their answers. And so they substitute their answer, for example, in the usual algebraic equation building, problem solving, routinary problems. We usually ask students, to check whether the solutions were correct as they replace values on the equations, and only to realize that some of the students, almost all of the students, got it right. They were able to balance it, to equate it. But why is it sometimes that they are having different answers, but yet they were able to balance it and equate it? So in other words, it's not about just a mechanical computational thing, but it has that they are students or very good problem solvers see that what they are doing is reasonable and logical and correct. So it's not just a product of the usual computational thing, but has something to do with reason and with logical assertions and meaning and justifications on what they have arrived at or what they have done as a process. So meaning problem solving is really, really a very big active process of thinking. So the conceptualization of mathematical solution strategy for routine problems involves a metacognitive function in formulating equations, algorithmic approach, and trial and error. So these are the common patterns of written solutions that were derived from the responses of our successful problem solvers. They formulate equations, do some random numerical trials, they do some algorithmic approaches, computational approaches, no, in order to arrive at the right solution. But for non-routine, they are usually product of insightful or novel inductive and deductive analysis and reasoning, or of sophisticated utilization of already known heuristic mathematical strategies like case analysis. They make use of that. The means end analysis, they're very good in using available information or knowledge already about existing strategies that they can use as a tool to apply their mathematical knowledge in order to arrive at the right solution path. So listing, drawing, guess and check, and making table. So it's a good thing to know this, because it will also give us a reason why sometimes we think, why is it that even how much we give our students a different strategies on how to solve a problem, yet they cannot solve the problem. No. Even how good they are sometimes in the mathematical knowledge, but if they lack also training on the thinking strategies, then the probability that they will not be able to succeed will also be present, will also be possible. So the execution of mathematical solution strategy routine involves metacognitive application of basic algebraic rules in solving formulated equations or basic numerical computations, and non-routine observe as metacognitive algorithmic calculations, non-verbal, that involve fluid numerical reasoning, which is both verbal and non-verbal. So the examination of the open codes are also derived from the written solutions at the same time. We can see that very good problem solvers, even if they are doing trial and error, but when they write their solutions, really, really very neat. It's very organized. They have a very fluid numerical reasoning. So we can see the balance of the presence of both verbal and non-verbal ability, while others were able to successfully answer the problem. But if you look at their paper, it's so disorganized, but it's more about numbers. They can just, if you look and try to look at the patterns of where they're going, you really have to follow, because they write anywhere. And I think some of us are doing that. When we solve problems, some of us are, especially if we are highly non-verbal, we depend and rely on codes. No? So they write anywhere. No? Unlike those with fluid numerical reasoning, it's very, very clear. And they can just finish answering the problem in 1 or 2 minutes, very, very quickly. So the successful solution outcomes that we're talking about here, actually, in this study is already set to be given, because the basis of analyzing or getting the model of thinking patterns were taken from these successful responses. Okay, so they are the correct solutions to problems that have shown the following qualities. Number 1, solutions are logical and valid mathematical solution strategies. Second, accurate interpretation and utilization or application of mathematical facts, concepts, and procedures. And of course, there's precise calculations, because oftentimes if our students will not be able to calculate precisely, we call it oftentimes as carelessness, to our students. And we also have even experienced that when we were students as well, that we are so careless, even in performing simple arithmetic operations. So these are the 3 important qualities present in trying to identify successful solution outcomes. So if I may give to you again the emerging grounded theoretical framework of successful mathematical problem solving, this is already a complete picture of it. So you can see here the leftmost, we have the 6 themes, and we can organize them. The first 3 as metacognitive problem solving task related knowledge, and the last 3 of the 6 as metacognitive problem solving affect and motion experience as a driving force. And these are all caused by the nurture factor. As they grow, they were able to develop all the skills and abilities that they have. And constituted much on the emergence and as well as the utilization of the 10 micro metacognitive processes, which we call the cognitive solution qualities, or the control character of problem solving, task related knowledge, affect, and motion experience. Okay. And these consequently affect, as a systematic grounded theory design of Strauss and Corbin, these constitute to the stages, the strategies. Okay, so the strategies is the big understanding process. We called it as our conjoining stages of problem solving, where it encompasses conceptualization, the two important big thinking patterns or processes, conceptualization and execution of mathematical strategy. So the big part, the big challenge for us is how to really design lessons that will improve conceptualization ability of our students in finding solution paths that would lead them to successful solution outcomes. The rest are procedural and calculation skill-based, numerical skill-based skills. That would lead it to the consequence, the problem solving goal, which is the successful metacognitive mathematical problem solving outcome. Okay, so it proposes therefore the 7 metacognitive thinking processes in successful problem solving outcome. So this study highlights some implications in the teaching and learning of mathematics and related or allied fields with 4 important points, namely the important role of developing metacognitive thinking skills and strategies in learning and achieving accurate mathematical content knowledge and thinking as one. The integration of affective and psychomotor skills and metacognitive thinking development in mathematics, and the understanding of the important function of the micro-metacognitive control processes in daily lessons, social interactions, and responsibilities at home and the community. A paradigm shift or development in understanding of problem solving for successful 21st century teaching and learning in mathematics and allied fields. And more educational researches or action researches may provide further developments in the field. So we can have some messages to educational policy writers, but first and foremost, this result can still be expanded into more other studies. It's wise that we can begin giving message to our classroom teachers, develop and test metacognitive problem-solving lesson exemplars, which prototype learning experiences that exercise each of the micro-metacognitive qualities for a more effective mathematical content learning gains. We can also promote enriching our students' experiences, more time be given on problem-solving activities. We can give them problem-solving as a means, as a teaching strategy to learn concepts in math, to learn skills, but making problem-solving scenario as a platform for them to understand new mathematical ideas that we want them to learn. But at the same time, they are already connected to how it can be applied in a sense, or in the sense of doing the problem solving. So promote and increase realization of the value of one's personal strength, positive emotions, beliefs and values, and attitude toward attaining successful mathematical problem solving. Integrate reading and writing in the process of developing problem solving curriculum, as the former was found as scaffolds that efficiently and effectively sustain or increase metacognition. So for family, school, and community, develop a nurturing habit of a composed, reflective mathematical mind. That's why there are some trends going on right now, calling for the habit of mind, become more mindful. That is really healthy to our children's holistic development. Learners achieve multifaceted thinking skills and thinking strategies and conduct further research, local or international, to explore the other unfound metacognitive processes and its attitudinal or bodily affiliations that are vital to the development of the teaching and learning of mathematical problem solving. So this initial endeavor in studying how young learners, practically in the Philippines, think as a result of either nature or nurture, provides a very promising future in advancing our very own habits of a composed, reflective, or metacognitive mind, which eventually may impact direction not only in successful mathematical problem solving, but in our general way of learning, reading, and living. So to end this part before the question and answer, I may say also that when we look back at Spady's total human qualities, wherein at the heart of the five important elements of it is a spiritual and conscious total learner. So if you are praying, if you are meditating, that is where metacognition is also happening. We reflect on what we did. We try to see if what we planned out work, or if we did something right or wrong, or in what way we can more improve what we have done or what we have created. So these are the things, no, that where we can find. These are the experiences where we can find metacognition. So, and well, I see and I believe that metacognition, as part even of the physical structure of our brain, no, be explained by even the theory of Loria as early as 1970s. This a part of the body that is being provided with, no, the ability to think, transcend higher than what we just usually perceive, what we just usually given attention and notice. So we have to think in a more transcending manner. And that's, I think, where transformational education can come in. When we become more reflective, when we become more mindful, it will become our habit to think, to reflect, and to regulate what we are doing, what we are thinking, what we know, and what we can do. So I think that's all that I can share for this study. Okay, thank you so much. So I'm giving you again the reflection questions. It can be a takeaway question. You can bring it with you, and we can now entertain questions.
Okay, thank you once again, Dr. Lovella. So do you need some break or we will be continuing?
We can continue. We can entertain questions
Okay,
now.
fine. So we have received a lot of questions. So let me raise one by one. First of all, I would like to mention the question from Dr. Wazid Hussain. So he's asking, how do you implement assessment of metacognition?
Yeah, in fact, we have tried it out even in the graduate school, but of course we have to be very careful. No, when we try to ask reflective questions, it has to suit as well to the level of the learners. So in my assessment task, it's a reflective question, even on the application of what they have understood in a particular mathematical facts. So you can just ask them. If you are giving a problem, for example, and then you have to ask them to choose, which do you think is the mathematical concept that best suits to provide you a more informative or a more effective and efficient mathematical knowledge to answer a particular problem. So that's an example. So it's how creative we are in asking assessment questions to our students. So in that case, it does not focus on the correct answer, but it focuses on the exercise to think. The exercise to think. Because remember, the function of assessment is not only to check how much they have earned or how much they have gained or achieved, but it's also a reinforcement of learning. So if we are in the OBE perspective or paradigm, we all believe that learning does not take place at the same time to all learners. Our learners have a different pace of learning. So in other words, we elevate the opportunity, we expand the opportunity for our students to achieve success. So you would know which of the students will be able to, if you can even do that in a multiple choice type of depth and make them reason out. Because from reasoning, communicating, remember one of the fundamental life role performance, when we ask our students to orally give their justification or reasoning why they choose that particular option, that also exercises their metacognitive thinking. So, but when you test metacognitive thinking, it's a very difficult construct to give a value, but you can still set a value if you have a rubric. So you just have to come up with a criteria. No, if I am asking a question that would give me an indicator or an information that my student has already arrived at the achievable, the expected, the desirable answer, then come up with your own criteria of what is that desirable answer that your students based on his justification or answer. Okay, and then you can come up with so many other creative means of doing assessment using metacognitive strategies. Just let them think, just let them reflect, and you would see how different one student answer from another student. And of course, as a professor, as an instructor, as a teacher, you always have a kind of a desired answer in your mind when you ask questions to your students. We've been used to multiple choice type of tests, but even that, it can be used as a tool to expand, to make use of metacognition by allowing our students to expand answers, to justify, to communicate what they have in mind about it. But designing of a different assessment tool for your students to answer reflective questions, that can be another thing. That's a challenging part. Make use of the microprocesses. If you believe that these 10 microprocesses are beneficial, make use of them. They are your guide. If my students can predict, if my students can diagnose, so you pose questions, problems that are faulty, then you diagnose, you let them diagnose. Okay, or you let them interpret. There is an ideal scenario, you let them interpret, and then let them write it down or let them say it. And then there must be something in you, that you want to look for in their answers. And when you notice that that particular answer, that particular element of the answer is faulty, then you can start asking, rethink. Okay, which do you think, say for example, you give the feedback right away, okay, it's wrong, and then you ask them, which do you think is the part of the thinking that you failed to do. Okay, then there's always a way if we are creative enough. Okay? As long as we are guided by the theory, we are guided by all these elements. Okay, we can always come up with assessment, whatever kind of assessment, very creative assessment in a way that we want it. As long as we know, we're very clear to us what we want our students to manifest or to demonstrate. Okay, I hope I have answered your question, Dr. Wajid.
Thank you, Dr. Lovella. So if Dr. Wajid has some other questions, he will be asking again. So I am coming to the question of Abdullah Mahmouda. He has asked, cognitive thinking is just a guess or a knowledge? If it is a knowledge, how are we going to apply in the classroom where students are from different cultural background?
Okay. Cognitive thinking is a process. The knowledge is a tool that we take into that process. That's why we call that cognition. Okay, so that is why if you can remember, Sternberg clearly emphasized the 3 layers. The first layer, the lower layer, is the ability of the mind to acquire information. Okay, knowledge, meaning there is the, if you encounter the information processing theory, it's like also a computer with a storage box, no, the recycle bin. So that's where knowledge is being put into. So if you liken brain, okay, to the CPU, for example, they are not equal, of course, they're not the same, but more or less. Okay, so knowledge is being deposited too. So the process of of doing something with the knowledge is what we call the performance level. We call that at the cognition level. What are you doing with that knowledge? So at the lower level, the brain acquire it. Piaget's theory explained it's either accommodation or assimilation. So if you assimilate the knowledge, okay, you take it in, okay, you understand to be that is the knowledge. Okay, that's how I understand it at the very minimum. But later on, you will realize that this knowledge can also have another meaning. So that's when you see transferability of understanding of that particular knowledge in a particular context, in a particular field, has a different meaning, then that is now an accommodation. Okay, when you're able to look at a brighter or bigger perspective rather, or a wider context of application, that's where accommodation. So the process of assimilation, accommodation, this is where what we call the acquisition process. And now in the other tasks now required in the cognition, that's the processes. Okay, I'm not a qualified psychologist to explain all of this, but I just read them. But more or less, how to differentiate the two, knowledge and cognition is different. Knowledge can be a tool. At the minimum, we acquire it. When we put it in our brain, we process it. That is cognition, when we are already processing or using it, like in problem solving. But according to Sternberg, there is another higher level of function of the brain. We call that the higher executive function. Many scientists are working on that. Many scientists are studying higher order cognitive processes. But the sense that meta is higher, so metacognition is defined in the field of education as a process of regulating something. So but what is that something? Dahil it's metacognition, so it's regulating the cognition. Okay, so in other words, what was the point again? Sorry, I missed that. If it is knowledge, then what was that, Dr. Islam Mutaharul?
Yeah, just a minute. Okay, so the question was, cognitive thinking is just a gaze or a knowledge? If it is a knowledge, how are we going to apply it in the classroom where students are from different cultural background?
Okay. Make use of the context of your students for them to reflect. Okay? Because you might be having a different understanding and you said knowledge, if it's just a knowledge, and cognitive, knowledge is a tool, all right? But cognition is a thinking process, all right? So in other words, make use of the different contexts of your students as a knowledge, okay, for them to be able to think well, especially if they're coming from different cultural backgrounds. And I think that's one reason why, if you look at the international testing, for our basic education, why is it that many of us, especially in our country, are not doing well? Many of us in the Asian countries are not doing well in the international testing. One thing to examine also is the context of the questioning, because there might be several or many possible questions that might be alien to the context or to the culture of our students who are taking the test. So that's one thing. That's a good question. That's a good reminder to us that culture is really very important when also considering assessing our students' performances. Okay. So we become more reflective as teachers. The more we become reflective in our decision making, the more we become more metacognitive, the more we become more conscious, the more we can have a better decision making in whatever we do inside our institution or even outside our institution practices. Okay, I hope I have answered that.
Thank you, Dr. Lovella. So the next question has been asked by Harun Ahmad. So his question is, is that this system can enable a student to look at all his issues with open heart and solve them easily?
Solve them easily. Issues open. What do you mean by that?
Okay,
The
I
way
am reading the.
Okay,
So
can you read it again? I am
yes,
I might.
so the question is that system can enable a student to look at all his issues with open heart and solve them easily?
What system are you referring to?
So
System, are you referring to the pattern of thinkings that are
it's
being
not mentioned
presented here?
here. Is that system so is that system can enable, that means the system you are representing, the metacognitive
Oh,
system,
okay,
I think.
yeah. Right. So is that system can allow our students, yes, helping our students to become more reflective, become more mindful. That can even help them improve themselves. It can help them improve. Yes. If you want, you can conduct study about that so that it become more empirical. It might not be easy because, of course, it's no such as overnight thing. It's always a process. But yes, we put hope to it that whenever we encourage our students to become more reflective in what they are doing, even in before deciding for something, even in what they choose, teaching them how to choose what choice. Well, that it by itself is an exercise of making them reflect before making their choices. So yes, I do agree with that. But to be easy, well, it takes a while.
Okay, thank you, Dr. Lovella. So there is a question by Mulugeta Tesom. He has mentioned, I have great appreciation for you as you have addressed an important issue. Now the question is, do you think all the issue you have communicated help to boost students' performance in the classroom and enable them to be a good problem solver?
Okay, actually, this is still in its initial stage. Okay, I may say it's still it's like it's still a baby stage. So I think it would require. That's why my suggestion it's for classroom teachers, for instructors and professors to try this out and expand further on these thinking patterns and the other possible ways that we can make use of them to help our students improve their problem solving abilities. So we can try it out. But as of now, it's too early to say. But I do believe we have hope for that now that we have clearer phases of what thinking patterns are needed for our students to manage well their thinking when they answer problems in mathematics.
Okay, thank you, Dr. Lovella. So we have received another question from Izari Mashita. So develop my critical thinking more and I will explore my students' ability in study language by using metacognitive strategies in the classroom. So he will be applying your concept in the classroom as he mentioned. The next thing is a systematic method for analysis, design, prototype development, improving the. So the question is not clear. So we encourage you to write your questions from the in the question tab. So it will be helpful for us because there are two tabs, discussion and questions. So some of you are asking question in the discussion tab. Please ask the question in the question tab.
Dr. Mutaharul, I think the first one stated is not a question, but an insight on how to make use of the that's an insight on how to make use of the findings of the study. But the second one, can you repeat that again, Dr. Mataharu?
Actually, this not the question. Just some. I mean. He has mentioned some issues. So I think we can again revisit the question asked by Dr. Wazid Hussain. So how do we implement assessment of metacognition? If Dr. Wazid has some other issues relating to this question, we can extend it.
Okay, so how we can implement metacognition in assessment. Okay, I think I have answered that to Dr. Waid's questions just a while ago. So it's the same thing. Be creative as long as the focus is on the development of their thinking instead of looking at the correct answers. But of course, it's only one of the indicators. If the answer, we can make use of the answer as an indicator where to find the faulty thinking pattern or where to find thinking pattern to be improved. Okay, so for example, if there is a question, a concrete objective question that would be equivalent to objective, concrete, objective, true or false, 0, 1 answer, then go back to the thinking. Allow your students to also answer questions that would somehow give you an indicator why such objective answer that can be corrected by 1 or 0, correct or wrong, okay, a justification of the answer. So we can always make use of a rubric, come up with our own criteria of what desirable answer we are looking for our students that would reflect their metacognitive thinking. Make use of the microprocesses.
Okay, I think we have already reached to the end of the session. So I would like to thank wholeheartedly to Dr. Lovella for your very nice and excellent presentation. Although it is conceptual, hopefully we will be applying this concept in our teaching and learning, and it will be much more helpful to boost up the knowledge of the, our beloved students. So now I have some announcement. I have already mentioned in the discussion box. So in 4OB, we are, we have a virtual summit, the Global Virtual Summit. It will be on next August, 12 to 14 of August. So please, join the In4OBE Virtual Summit. And you are also requested to submit your proposal. I have already given the proposal submission. The deadline is June 10, 2022. And you can also, get the emails to the, Dr. Wazid Hussein's email. I have given it to you, so you can submit your proposal, and you can consider also the proposal submission. And I would like to thank you all for your kind presence from all over the world. And it helps us to conduct this webinar very successfully. And we would like to, invite you all for the next webinar, because it is a series of webinar services. So in the next webinar, you will be also joining, and you can also enrich your knowledge base. And another thing is, you will be, this all the webinar series, we are getting the professional certificates. So at the end of this session, you can access our Vertex system to get the professional development certificate. It will be available after a few minutes, so you can easily download that. So that's all for today's session. Thank you once again. I thank you on behalf of In4OB, and I also like to thank you all on behalf of United International University, Bangladesh. It's a top-ranked private university in Bangladesh. So hope to meet you once again in the next month.